going from, let's say, fraction to decimal, decimal to fraction, okay? We're just changing the way we're stating something. All right, do these three, and then I'm going to call on three people to tell me what it's supposed to be.
So do we need to go all the way, like, to get, like, 1/16 equals 1/16? Or just...
No. No. I don't want you to show me what it works out to be. I just want you to take those numbers and rearrange them correctly using exponential form.
Is this all we're doing for the moment?
No. We're going to convert the other way, and then we're going to evaluate.
Why'd you attack the
Because it went out, which really doesn't matter anyway, but
She wants to watch yourself in the camera.
I want to make sure all my stuff's in the screen. Okay, so let's start with this one. Taylor, what is this?
2 to the negative 3 equals
2 to the negative 3 equals 1/8. Perfect. Perfect.
Because
Leave
1
it
half
like
to
that.
30.
Who said what?
You can leave it with the negative.
Yes, that's how I want you to leave it. I want whatever numbers are in here, I want those same numbers to show up here. Okay? I don't want you to change them around right now. I just want to see that you understand what they represent. Okay. Josh,
Yeah.
this log 25, 5 equals 1/2. How should that be written?
25 to the 1 half equals 5.
Excellent. 25 is your base, 1/2 is your exponent, 5 is the solution. What does something to the 1/2 power mean?
Square root.
Square root. Square root, right? Yeah. So yeah, that's basically saying the square root of 25 is 5. All right, and then finally, Addison, how should this one be written?
7 to the 1 to the negative 1 equals 1/7.
Excellent. 7 to the negative 1 equals 1/7, which is absolutely correct, because the negative exponent says that I take the inverse of 7 and turn it into a fraction. Okay, so does everybody feel comfortable with taking a logarithmic expression and turning it into exponential?
Figure streets for me.
Now let's do it the other way. Which, once again, whatever numbers you start with, that's how you need to end up. You're just going to have the word log involved there now. All right, so let's start with
What value do logarithms have in real life?
great value. NASA uses them. Chemists, doctors,
We did logarithms in
pharmacists,
chemistry last week. We did in chemistry last week.
all kinds of stuff. I'm sure they're used in just the water systems and measuring amounts of chemicals and things and pollutants and whatever in the water. The Food and Drug Administration, putting limits on how many,
Oh, the FDA.
you know, of whatever contaminants are in food before they finally decide, okay, that's too many contaminants, it's going to make people sick. All right. This is an exponential expression. We're going to take it and turn it into a logarithmic expression. Remember, here's my base, here's my exponent, here's my solution. It's simply recalling where do these three pieces of the puzzle go when you write it as a logarithm. My base goes here, right? So it's log with a base of 10. My solution goes here. And my exponent goes here. So taking an exponential expression and turning it into a logarithm. Did I change the value that I'm talking about? No, I'm just changing the way I look at it, or the way I state it. All right, let's do another one, and then you're going to do 3 on your own.
How would you put log 10 1000 minus 3 in the words?
I'm coming. I'm not ignoring you. I want to make sure I say it correctly. Let's write that one as a logarithm, and then I'll read it to you. Orland, what is this as a logarithm?
No, log of 9.
log 9 of 3.
Actually, it's read 1/2 is log base 9 of 3. Is
So,
how you read it.
the other
1/2 is log base 9 of 3.
So the other one would be 3 is log
Base 10 of 1,000. Exactly. All right, now let's put you some examples up here for you to work out on your own. And then we're going to start evaluating the expressions. Okay, write these down, and let's see if you can do it. Okay, I wanted to make sure this one fit on the screen. It does. Okay. All right, y'all done?
Yes.
Aaron, how do you write the first expression as a logarithm?
5 is log base 3 of 240.
Excellent. And he even said it right. 5 is log base 3 of 243. Your base, your exponent, excuse me, your solution. Danielle Duhon. Duyon. How do you say your last name? Duyon. Okay. Never mind. Okay. How do you write this as a logarithm?
The log to the base of 3 of 243 equals 5.
Oh, no, no, no. We
Wrong
just
one.
did that one. This one. Second one.
Okay. Log to the 10 of 1 over 1,000 is equal to -3.
Great. Perfect. That's correct. We can also read it log base 10 of 1/1000 is -3. All right, how would we write this one, Renee? This last one?
Log base 4 of 164 is
Excellent. Your base, your exponent is on the other side of the equal sign. Your solution follows the word log. Okay, are we comfortable with this, going from one way to the other? All right, let's evaluate now.
When's our test on this?
Monday.
Is it a 50-point test or is it
It's another 50-point test. I can't give you 100 points on one section.
You should.
It's just, I can't bring myself to do it. All right.
We have a lot of 50-point tests in here.
Did you get our test from yesterday?
Yes.
I'm working on it. I started to. I spent about 2.5 hours grading, and I decided that was enough.
You should have Scantron method.
I spent 10 hours grading Sunday. At my table, getting up only to potty.
Wait, what?
I'm not doing that again. Okay. Evaluate log base 2 of 64.
Yeah.
Okay, now we're going to take what we just learned of how to turn this into an exponential expression, and then you'll see that we're going to apply what we did on our last test, evaluating an exponential or solving an exponential equation.
So we just put an exponential and solve it.
Yes, because right now, see what we just did, we had an equal sign and we had a number here. But right now, is there a number here? So if there is no number, it's represented as what? X. And so if my base is 2 and X is my exponent and my solution is 64, does this look familiar?
Yes, it does.